So we have a function here, f of x, and they want us to determine if it's even, odd, or neither. Okay? So we always plug in f of the opposite of x, and we see what happens. Now in this case, when we simplify, we would get negative x cubed minus 2x. Okay, so think about the simplifying there. Now, it's definitely not even, because in order for it to be even, this would have to be the same as what we started with. And we've got the opposite of x cubed minus 2x. That's not the same thing as x cubed plus 2x. So it's definitely not even. Is it odd? It might be odd. We might have to do a little bit more work to show that. So if I want to think of it this way, I could say this is equal to the negative, the opposite, I was going to put negative 1, but the opposite of x cubed plus 2x. Okay, is that the opposite of the f of x? And the answer is yes. So if you want to see that, I'll try to write it out a little more here. The opposite of f of x would be the opposite of x cubed plus 2x. And you get to distribute that if you want, but those match up. Okay? So that's what we're doing here when it's an odd function. You're checking to see if it's the opposite of the original function. And in this case, that means distributing there. So you get, the opposite of x cubed minus 2x. Okay? So this does turn out to be an odd function. So you check to see if it's even, then you check to see if it's odd. If it's not either one, then we would say it's neither even or odd. Okay? But this one is an odd function. Means if you were to graph it, it would be symmetric about the origin. Okay? And you could graph it and check that out. All right, so that's it for the test on even and oddness.